أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Let's review our previous lecture in order to get some important hints. For example, you can see in this slide that as the line AB is parallel to one of the plane, that is in this case to the vertical plane, so its projection on the vertical plane, that is the front view, will be of true length, and the front view must also appear with the true inclination, that is theta, with the xy reference line. And the other view on the plane to which the line is inclined, in this case to the horizontal plane. So on the horizontal plane, the projection will be shorter than the true length. Also, that projection, or in this case the top view, must also be parallel to the xy reference line. So if the line is inclined to one of the plane, so its projection on that plane must be shorter than the true length, and that projection must also be parallel to the xy reference line. So if one view, in other words, you can say that if one view is parallel, in this case the top view, then the other view, that is the front view, must show the true length. Or vice versa, if one view is the true length, then the other view must be parallel to the xy reference line. Now, if we move the end B to this new position, now the line becomes inclined to the vertical plane as well. Initially, it was inclined to the horizontal plane only. You can see from its end distances. And A has this much distance, and B has some greater distance as compared to ends A distance. So the line is at this instant only inclined to the horizontal plane and is parallel to the vertical plane. But if we move and B to this new position, now the distance of and B, now the new annotation is B1 for this end. Now you can see that the B1 distance from the vertical plane is greater than the ends A distance from the vertical plane. So the line becomes inclined to the vertical plane as well. Now what happened to the front view and the top view that was previously seen? Previously the front view is of true length and is inclined to the xy reference line at an angle theta, and the top view is parallel to the xy reference line and is shorter in length as compared to the true length of the line. Now if we make the line inclined to the vertical plane as well, now what happened to that top view and what happens to that top view and that front view? So you can see that the new top view by projecting this and B1 onto the projection plane, that is the horizontal plane, to this position. And as we haven't moved and A, so the projection of and A remain at the same position. And when you join these 2 points, so we get this new top view AB1. Now this new top view AB1 doesn't remain parallel, doesn't remain parallel. It becomes also inclined to the XY reference line. You can see the length remains the same, but the angle has changed. It was initially parallel to the XY reference line, means that the top view was making no angle or was making zero angle with the XY reference line. Now it is making some angle other than 0 degree. So the top view becomes inclined, remained of the same length as was uh, previously. And what happened to the front view? The front view, which was initially of true length when the line was parallel to the vertical plane, but now the line has been made inclined to the vertical plane. So the new front view, looking at the end B from this side and looking at the end A, sorry, from this side. So its projection would be projected to this point on the vertical plane, and B1 would be projected to this location on the vertical plane. When by joining the 2 points, you get the A prime or A dash B1 dash or A prime B1 prime. So the new top view now becomes shorter than the true length and also is appearing at an angle greater than theta, and this apparent angle will be called alpha. So these were the few hints. Now let's see another line which is initially inclined to the vertical plane only. You can see or judge its ends distances from the vertical plane, and B is at this much distance, and B and A is at some large smaller distance as compared to ends B distance in front of the vertical plane. So the line is inclined to the vertical plane. Now with respect to the horizontal plane, as and A is at the same distance above the horizontal plane as and B is. So the line is parallel to the horizontal plane at first instant, at this instant. So the projection on the plane to which the line is parallel must show the true length. And in this case, the line is parallel to the horizontal plane. So the projection that is formed on the horizontal plane, that is the top view. Always the top view will be formed at the horizontal plane. So the top view must show the true length, projecting end A onto the horizontal plane and projecting end B onto the horizontal plane, and then joining these 2 points with a straight line segment. So you will get the top view. And the top view is of similar similar length as the line itself is. So, in other words, the top view is showing the true length. And also, you can see that the top view is appearing at an angle phi. The true length must appear with the true inclination pi with the xy reference line. And look at the front view. As the line is inclined to the vertical plane, so the front view, looking at the end A from this side and looking at the end B from this side, these two projectors, this one and this one, must remain parallel to each other. You can see it here, you can judge it from its parallelism, and also must remain perpendicular to the vertical plane. So, in that case, and A would be projected to this location on the vertical plane, and B would be projected to this position or location on the vertical plane. And when you join these 2 points, two endpoints, projection of two endpoints, so you will get its front as a line having ends A dash and B dash. You can see that the front view is shorter than the true length because the line is inclined to the vertical plane. Now, the projection on that plane to which the line is inclined must be shorter in length. So, the front view is shorter in length but is parallel to the XY reference line. So, you can see that if the line is inclined to only one plane and parallel to the other plane, so one of the view, in this case the top view, must be of the true length, and the other view, that is the front view, must be shorter than the true length but must be parallel to the XY reference line. So again, as we have seen previously, if one view is true length, then the other must be parallel to the XY reference line, or vice versa. If one view is parallel to the XY reference line, then the other view or projection must be of true length. Now, if we move this end B to the new position B1, making the line to be inclined to the horizontal plane as well. You can see the ends distances. Ends A is now at the same distance because we haven't moved, and A is at the same distance above the horizontal plane, but and B1 is at some greater distance as compared to ends A distance above the horizontal plane. So the line is now inclined to the horizontal plane as well. So it was initially inclined to the vertical plane. Now we have made it to be inclined to the horizontal plane as well. So the line becomes inclined to both of the planes. Now what happened to the previous projections? Previously the top view was of true length and the top view was appearing with an angle pi, that is the true inclination with the XY reference line. Now the new position AB1, so the top view, the B1 will be projected onto the horizontal plane at this position. The top view of ends A remain at the same positions when you join these two, so you get the new top view AB1. Now this new top view becomes shorter than the true length because the line has become inclined to the horizontal plane as well. So I have told you that if the line is inclined to a plane, so its projection on that plane will be shorter as compared to the true length of the line. So the top view becomes shorter, and also the top view is now appearing at greater angle than pi. This angle is called beta, or the apparent angle beta. Why it is called the apparent angle? Because we haven't changed its inclination with the vertical plane. The inclination with the vertical plane remains the same. That is the pi. But the effect of making it inclined to the other plane as well has this has affected the appearance of the top view, which is now appearing at some greater angle than the angle of the line that it actually makes with the vertical plane. Because we haven't changed the angle with the vertical plane, it remains the same. But initially, this is the angle with the vertical plane, that is pi. Now, if the line is parallel to the horizontal plane, so this pi will appear with the top view, and the top view will be of true length. But if we make the line to be inclined to the horizontal plane as well, and we haven't changed the inclination with the vertical plane, it remains the same. But the angle that the top view is making now with the xy reference line is greater than pi. This angle is called the apparent angle beta, which is basically the effect of the inclination of the line with the horizontal plane. And look at the front view. The front view, which was parallel to the xy reference line initially when the line was inclined to the vertical plane only. But now, as you have made it, as we have made it inclined to the horizontal plane as well, so the front view will also be making angle greater than 0 degree, and this new angle will be called alpha, because initially this was the angle that was parallel to the xy reference line. So you got the point. Now, other thing that has to be remembered is that always you can see that angle theta as well as alpha will appear with the front view. are the end of the front, the angle theta as well as the angle alpha. And the other is a little bit clearer. This slide, you can see that always the angle theta and the angle alpha will appear or will be uh, made with this A dash or will start from A dash. That is the end of the end of the front view. Also, the locus B dash and the locus for the shorter front view will be on the same line. That is B dash and B2 dash will appear on the same locus or on the same line. Also, you can see that the angle pi and the apparent angle beta will always appear with the end in the top view. And the other end top view, that is B1 and B2, will lie on the same locus. So these are some of the hints that must be remembered while projecting lines.